Okay, so I want to make another video here about shock angle because, by now, this was a couple of years ago, I made a part of my setup tutorial series, a shock angle video, and I feel like I got a few things wrong in that video, to be perfectly honest. And I received some, well-deserved criticism for that. So I want to try to give some corrections or more accurate information on how shock angle can affect your handling and your jumping performance in your off-road car. So one of the things I pointed out in the original video was that as you lay the shocks down, that makes the shock effectively stiffer during compression, like if you're landing off of a jump, and effectively softer if you're cornering. It's kind of sort of true. And the reason for that is because the way you lay the shock down matters. So for instance, if you're increasing the shock angle by moving the shock at the top mounting point on the tower, that's actually going to have a different effect on the relative stiffness of the shock than if you increase the shock angle by moving it along on the arm side. And there's a simple reason for this. It basically has to do with leverage. Okay, so your arm, your suspension arm, is like a lever. Okay, and the further out the shock is along the arm, okay, the less mechanical advantage the arm has on the shock to compress the shock. Okay, so your absolute stiffest shock setup would be a theoretical setup where you have a mounting point way out here and a shock tower that goes way out here and the shock is completely vertical. Okay, that would be your theoretical stiffest shock setup. And your theoretical softest shock setup would be if the mounting point is all the way on the inside and you have a shock tower mounting point all the way on the inside. Because in this case, if the shock is all the way on the inside, the suspension arm has the most mechanical leverage or mechanical advantage on the shock. It has more leverage, okay? Kind of like a seesaw where you move the fulcrum back and forth. So what's effectively happening if you take let's suppose I keep this mounting point here and I start at the top of the shock and I start moving it inwards and I'm laying the shock down. There's two things that happen. The first is that the average mounting location of the shock moves toward the inside. Okay, if you just take this location relative to, this, I don't even want to call it a center point, but this acts as a rotation here, you draw a vertical line upwards. The distance from here out to this point and out to this point, that average distance drops as I move the top of the shock inwards. Okay, so that means effectively I'm moving the whole thing inwards by some average amount. So that's going to make the suspension a little bit softer. Okay. However, let's suppose the shock is all the way on the inside mounting hole here, inside mounting hole in the arm. Now, I take the bottom of the shock, I move it outwards on the arm. Okay, I'm laying the shock down as well. The thing is, now what I'm doing is taking the average mounting location of the shock and moving it outwards. So relative to that initial starting point, the shock's getting stiffer. And then relative to the initial starting point over here, the shock's getting softer as I move it in or out. Okay, so now consider you have the same exact shock angle. I keep the shock angle constant, and I just move it in and out. So maybe I move this out one hole in the arm, and I move this out one hole in the tower, so I maintain the same shock angle. What's going to happen? Well, that shock's going to get effectively stiffer. If I move it in, effectively softer. Okay? Excuse me, where do I want to go with this? So what happens is if you want to have, let's say, a better landing performance for your car or truck, generally, say if the chassis is slapping the ground, for example, which is something I've been doing a lot by, with my basement testing, with my various cars and trucks. If you move the shocks out, you'll get better landing performance. Now, what's the difference, by the way, between having a lay down shock where the average mounting location is, let's say, here, and a stand-up shock that's mounted exactly along this point. Well, the difference is the change in the rate of the suspension. Okay, so if the shock is perfectly vertical and I'm compressing the suspension arm, that shock angle is constant. Okay, but if this shock is laid down like this and I compress the suspension, look at what happens. You see how this shock moves out a little bit? So that means the shock angle is changing as a function of how the suspension compresses. That's what you call a progressive suspension. Okay, so as I compress the suspension, this is moving out. Okay, you see the arm, you see the shock here at the top, it's moving out this way. So what that means is the effective average mounting location of the shock is being pushed outwards as the suspension compresses. That means suspension gets a little bit stiffer the more the arms compress the suspension. Okay, that's what you do with an angled shock. So that's why if you have what is otherwise the same exact average mounting location for a vertical shock and an angled shock, that angled shock will give you better landing performance on your jump, because as the suspension compresses, it gets a little stiffer. With a perfectly vertical shock, that suspension rate, that effective rate, is constant throughout the entire movement of the arm. Okay, so this is why various cars, let's say this RB5 here, this Kyosho Pro X, an RC10T, whatever, has a slightly angled shock. So one of the things I was doing with my RC10T was trying to figure out how to angle the shock on the tower side more to angle it inwards. And I had some help with producing a shock tower that can do that. And although it does increase the progressivity of the suspension, it's still moving the mounting point inwards, the average mounting point inwards. So it actually wasn't, when I was testing it out off of this jump here, right there, it wasn't actually helping with bottoming out too much. But if I had a shock tower where I could move the mounting point out more, so that I can move the whole shock out more, that would make the rear suspension a little bit stiffer. And that, I suspect, in some version 3 tower, would actually help, for instance, with how the RC10T lands and chassis slaps on the track surface. So I just want to clear the air on that, because as you're tuning your shocks, you're gonna find yourself playing around a lot with shock angle. So one of the things I do is I say, okay, well, I'm doing all this testing, I'm going off a jump, I see the car bottoming out. Okay, why is that? Well, is it bottoming out on the front or the rear? Let's say it's bottoming out on the rear. Okay, where are my starting points on my holes? If I'm all the way on the inside over here, and I'm, let's say, on the middle hole on the bottom, I can either move the bottom hole out, and that would make the average mounting point out a little bit, so that the suspension would be a little bit stiffer effectively, but because it's a higher starting angle, the progressivity of that suspension would also be higher. So as the suspension compresses, it would get stiffer still. So that's one thing you can do. The other thing you can do is to keep that bottom mounting point the same and move the top point outwards. That would also add to stiffness, but it would reduce the progressivity of the suspension. So there are 2 ways to reduce chassis slap, right? Move the top out or the bottom out, but each one will have a different effect on the shock angle. Okay, so that's something you should play around with a little bit to see whether you prefer to have that shock more vertical or more laid down. If it's more laid down, it also has an effect on cornering, which is what I talked about a little bit in the first video, where generally what I found is if you stand up the rear shocks, perfectly stand up, that makes the turn in a little bit sharper, because on cornering, it kind of feels like the suspension is effectively stiffer. Feels like it. And if you lay the shocks down, the chassis is going to lean a little bit more on cornering. Okay, so depending on your driving style and what you're looking at with your track surface, you might want to stand up or lay down the shocks. Okay, so just to recap, just because a shock is at an angle doesn't necessarily mean it's stiffer or softer than if it stood up. The angle, it's also going to depend on where along the arm and the tower that shock is mounted. Okay? And whether you're moving the bottom out or in, or the top out or in. They have different effects. I hope that helps to clarify the shock angle discussion. If there are any questions or any further debate, I'm glad to have it. And maybe I'll have to make a third video. We'll see. So in the meantime, thanks for watching.